Alright guys, so differences of squares. So difference of squares is another form of factoring. It has to have a few things though. One, it has to be a binomial, which we hopefully know at this point means it's a two-term polynomial. So it's only two terms. And then also it has to be subtraction, because that's why it's called difference of squares. And both terms have to be perfect squares. So that means square roots can be taken and you get a whole number. So the square root of 1 would be 1, square root of 4 would be 2, square root of 9 would be 3, square root of 16 is 4. So you have to be able to take the square root and get a whole number. All of these are indeed, we are going to practice difference of squares. But every time, is it two terms? Is it a subtraction? Are they perfect squares? And a times a is a squared. So if I took the square root of a squared, I get a. So that's how that works. So what we're going to do is every time we see a binomial with subtraction in the middle, we're going to do a set of parentheses with a plus and a set of parentheses with a minus. You're going to square root the term in the front. So the square root of 16 and the square root of a squared. So the square root of 16 is 4, because that's 4 times 4, right? Square root of a squared is a times a. So that's the front term. So we're going to put a 4a and a 4a. So whatever the first one in goes in the front of both factors. Then we're going to take this second number. So in this case, it's a 1. Square root of 1. 1 times 1 gives me 1. So we're going to put a 1 in the front, in the back of the first one, and in the back of the second one. So they're going to be exactly the same terms in both, but the plus and the minus is super important. And the reason it's a plus and a minus is because every time you take the square root of any number, no matter what, there's a positive and negative. The few times you haven't discussed the negative is because maybe it's the distance formula or somewhere that it doesn't pertain, where you can't have a negative distance. But algebraically, every time you take the square root of any number, you should get a positive and a negative. So we're doing square roots, so we have a positive and a negative. All right, so looking at number 2. 2 sets of parentheses. It's a binomial. I can take the square root of 25. I can take the square root of n squared. I can take the square root of 4. And it is subtraction in the middle. So I'm going to do plus and I'm going to do minus. So the first one I'm going to do is 25 and n squared. So I'm going to take the square root of 25 and the square root of n squared. And the square root of 25 is 5 times 5, so it's going to be 5. And the square root of n squared is n times n, so it's n. So I have 5n and 5n. The second number, we're going to take the square root of 4. So the square root of 4 is equal to 2 times 2. So we're going to put a 2 in the first one and a 2 in the second one. Remember, it's plus and minus. And that is all there is to factoring the differences of squares, like a perfect square, the different squares. This is factors. So this is a factor. These are factors. If it says solve, you haven't gone far enough. So that's just factoring at this point. To solve, you're going to take 4a plus 1, set it equal to 0, and 4a minus 1, and set it equal to 0. You want to get 4a by itself, so we're going to do the positive 1 over. It's going to become negative. So 4a equals a negative 1. And then we're going to divide both sides by 4, because 4a is 4 times a. So in this case, a is equal to a negative 1/4. The second one is a negative 1, so we're going to add 1 over. So 4a equals a positive 1. Divide by 4 again, because that's 4 times a, and the inverse of multiplication is division. So a is also equal to 1/4. So our solution set will be a negative 1/4 and a positive 1/4. Now, the next one that we did that we factored, we have 5n plus 2 equals 0. So again, these are factors. So if all it says is factor, then you're done. But if it says solve, we got to keep going. Factor and then solve. You can't solve without factoring. So it's a positive 2, so we're going to subtract it. So 5n equals a negative 2. 5n is 5 times n, so the inverse of multiplication is division. So n is a negative 2/5. We have a negative 2. We're going to move it over. So we're going to add 2 because it crossed that equal mark. So 5n equals a positive 2. Divide by 5 to undo multiplication. So n equals 2/5. So the solution set is a negative 2/5 and a positive 2/5. You may see that written as plus minus 2/5. because that's a positive and a negative. So plus minus. And the same thing for our fourth. Could be plus minus 1/4 because it is the positive and the negative of 1/4. All right, number 3. The cool part about this is the numbers don't change very much. I did mean to give you a little more differentiation than that. But the numbers are usually, they have to be perfect squares. So in a worksheet that's titled Difference of Squares, there's going to be a pretty small set of numbers that you're going to use repeatedly, because there's only certain numbers you can take the square roots and get a nice, neat number from them. So the first one, we're going to take 25x, and we're going to square root it. We know we're factoring because it is a binomial subtraction. I can take the square root of 25, and I can take the square root of 16. So I have a plus and a minus. So the square root of 25 and the square root of x squared, and that's 5 times 5. So it's going to be a 5 and a 5. X squared, remember, is x times x. So the root is going to be x and x. We're going to do the same thing for the 16. The square root of 16. And the square root of 16, remember, is what number times itself will give me 16. So 4 times 4. So times itself 2 times, because that's the square root. So 4 is going to go in the first one, and 4 is going to go in the second one. So at this point, we have factored. But if it says solve, we got to keep going. We're not done if we have to solve. So it's 5x plus 4 equals 0, and 5x minus 4 equals 0. That first one, that's a plus 4, so we're going to move it over by subtracting 4 from both sides. So 5x equals a negative 4. That 5x is 5 times x, so the inverse of multiplication is we're going to divide by 5 on both sides. So divide both sides by 5, and x is going to equal a negative 4 over 5. This one, we're going to add 4 to both sides because it's negative and it's crossing the equal mark. So 5x equals positive 4. Divide by 5. So x equals 4 over 5. So our solution set being a negative 4 over 5 and a positive 4 over 5. Or again, can be written plus minus 4 over 5 as well. And so that is your solution. So if it said solve, you need to set them both factor. You still have to factor. You can't get around factoring when you're solving quadratics. But then you have to keep going. All right. Pause the video. I challenge you to try this one. First one, 16x. 4 and 4 for 16. X and x for x squared. Do the same thing for 25 that we've been doing. So square root, what times itself gives me 25? That's going to be that 5 and that 5. It's the difference of squares, so we're going to do a plus and a minus. So again, this is factored. We have now factored it. From here, we want to practice solving. So these are our factors, or it has factored completely. Now to solve it, you're going to take the 2 and set them equal to 0. 4x plus 5 equals 0. 4x minus 5 equals 0. We're going to subtract 5. So 4x equals a negative 5 again. And then we're going to divide by 4. X equals a negative 5 over 4. We're going to add 5 over here because it's a negative. And as it crosses that equal mark, it's going to become positive. Divide by 4 because that's the inverse of multiplication. I can't say it enough. 4x is 4 times x. So to undo multiplication, we're going to divide by 4. So x equals 5 over 4. So our solution set is negative 5 over 4 and positive 5 over 4, or the plus minus 5 over 4. All right, number 5. So 4b minus 64, and there doesn't always have to be a number in the front. If it was just b squared, then we're just going to put a b and a b. They just happen to spit out a bunch of problems with numbers in the front, which is fine because we can do that too. Might as well practice it as ugly and messy as it can get. So we're going to take the square root of the first one. So remember, we're going to open up 2 sets of parentheses. You know there's a plus. You know there's a minus. At least that much should be on your paper, no doubt. Square root of 4 is going to be 2 because 2 times 2 is 4. The square root of b squared is going to be b. So b in both of them. And then we're going to do the same thing with the one in the back. And we're going to take the square root of 64. So what times itself is 64? If you need to, that's the calculator, and use the square root bar. So it's going to be 8 and 8. Again, we've now factored. Those are the factors. And then from here, we're going to practice solving. And to solve, we need to set them both equal to 0. So 2b plus 8 equals 0. 2b minus 8 equals 0. Move our 8. We're going to subtract it because it's positive. We're going to divide by 2. We divide because it's the inverse of multiplication. So b equals 4. Again, that negative 8 has to move. So it's going to be 2b equals a positive 8 because it goes on the other side of the equal marks, which means we use our inverse operation, or it just changes symbols, whichever way makes sense in your brain. And then b equals a positive 4. Uh-oh, that's a negative 8 over there. Eek. Positive 8 moves there, it becomes negative. So our final answer is negative 4 and positive 4 for our answer choices, or again, plus minus 4 for our solutions, answers, x-intercepts, roots, zeros. That's all the magic words that's going to do that. So number 6, I'm going to pause and let you try it, or actually you pause the video and you try this guy. What's the worst that can happen? I will say that we probably... Oh, need to back up. Hold on. Back up, back up, back up. Big problem. We could actually factor out a GCF. So this is not factored correctly. Our solution is perfect. But we always, and it's a great call out because I just made the mistake that everybody makes, you always want to check for a GCF first. So you want to make sure there's not something I can pull out to make my numbers smaller, to factor appropriately, because 2 and 8 both have a number in common that I could have pulled out of there. So 4b squared minus 64, I can actually pull out a 4, which is going to let me b squared minus, and I believe it's 16. 64 divided by 4 is 16. Yep. Sorry, factoring is incorrect. Sorry, guys. So now we factored out the 4. We have a b squared minus 16, so that's going to be differences of squares again, plus and minus. The square root of b squared is b. The square root of 16 is going to be 4 and minus 4. So ultimately, again, as soon as you solve it, it's going to still be the same thing because b minus 4 equals 0 and b plus 4 equals 0. They're just going to switch symbols. So b equals 4 and b equals negative 4. So our solutions are still the same, so not a huge boo-boo there. But if we were only factoring and they were grading it, that 2b plus 8 and 2b minus 8 would not be factored enough. All right, so with that said, since I made that mistakes, look at number 6 and think. The first thing you want to think every single time, especially when A is not 1. So the number in the front when A is not 1 is, can I pull out a GCF? And in this case, you can. 5 and 20, we can pull out a 5. So we end up with x squared minus 4. Now we have a binomial. You can take the square root of x squared and you can take the square root of 4. So we know we can do differences of squares again. It's a positive and a negative. Don't lose your 5, again, because it's part of the factoring process. Take the square root of x squared. So we have x and an x in the front. We're going to take the square root of 4, and that means we're going to have a 2 and a 2. So now we factored it completely because there's a 1 and a 2, and we know there's nothing smaller there. To solve, so this again, as I can't say it enough, this is factored completely and well done. Not like our last one where I found our mistake after the fact. Sorry, guys. So GCF is always something you want to try to pull out before you factor completely if you want it to be correct for factoring. Now we're going to set them equal to 0. So 5 is nothing. It's never going to be 0. There's no way. So x plus 2 equals 0 and x minus 2 equals 0. We're going to solve for x. That 2 is going to move across the equal marks. It's attached by addition. The inverse is subtraction. So it's going to be minus 2. That's a negative 2. So the inverse of subtraction is addition. So it's going to x equals positive 2. So again, for differences of squares, it must be a binomial. It must be a subtraction problem. So that's called differences. And they have to both be perfect square roots. So like this one's really funny because 5, you couldn't take the square root of it anyway. So the only way we could factor any further is by taking that GCF out. All right, great job, guys.